So is everyone able to prove that after multiplication, you are going to get volume equals to 2700x minus 165x squared plus 2x cube? Is everyone getting this?
Yes, sir.
Yes, sir.
Second part says given that x can vary, find the value of x for which v has a stationary value. You're going to differentiate this. Differentiation of 2700x is going to be 2700. 165x squared is going to be negative 330x plus 6x squared. You're going to set it equal to 0 and solve for the values of x. So what are the values of x coming out?
It's coming to 45 and 10.
45 and 10. Okay.
Yeah.
Are both values acceptable?
Sir, would 10 just be acceptable? Because if you take 45 minus 2 into 45, one of the sides would come negative.
Exactly. So only 10 is the required answer. Does everyone get this concept? Why are we ignoring 45 value and why we are accepting 10?
Yes, sir.
Okay.
Yes, sir.
This side, if you take 45, this side is going to be negative, and we know that the length cannot be negative. Okay. Find the equation of a normal to the curve y equals to x squared plus 8 over x minus 2 at the point on the curve where x is 2, x is 4. So you need to find the equation of the normal to the curve. There is a curve whose equation is given to you. There is a point x equals to 4 where if you differentiate, you are going to get the gradient of the tangent, and hence you can find the gradient of the equation of the tangent as well. But we don't want equation of the tangent, we want equation of the normal line. So we are going to find equation of the normal line. The normal, the tangent and the curve all pass through the same point. So what is the first step that comes to your mind?
Taking
You're
out
going to
gradient.
you're going to differentiate. So how am I going to differentiate this? I'm going to apply quotient rule. Please apply quotient rule and get me the value of dy by dx. Vu prime minus uv prime over v square. Don't need to simplify. We can just find the value of dy by dx at x equals to 4. Plug in the value of 4 and get me the answer, please. What is the gradient coming?
Sir, -4.
Is everyone getting minus 4?
Still calculating, sir.
Okay. Sixteen minus 24 over 4.
Yeah, that -1 is -2.
I'm getting minus 2. So that is the gradient. Gradient is minus 2. So that is gradient of the curve at x equals to 4. So we know that the gradient of the tangent is also going to be minus 2. Therefore, the gradient of the normal is going to be 1 upon 2, using the concept m1 into m2 equals to negative 1. Now for the equation, I just need one more thing, that is the coordinate. So if in the equation I know when x is 4, y is going to come out as 12, right? So the point is 4 comma 12. The gradient of the normal is 1 upon 2. Use this to find the equation of the normal. Y minus y1 equals to m x minus x1. Okay, that's your equation. If you want to simplify this, you are going to get 2y equals to x plus 20. Okay.
Okay.
All right. So is everyone done till here?
Yes, sir.
All right. Let's start with exponential functions. Now we are going to look at derivatives of exponential functions. Exponential functions have a special property that the derivative of exponential functions comes out to be the same. That is, if we have an exponential function and if we plot the gradient function of the exponential, they are going to overlap. So which means that dy as a rule, you need to remember this, that differentiation of exponential function is the exponential function itself. For example, e to the power of x differentiation is going to be e to the power of x. But if e is raised to this exponential function is raised to some power that is itself a function, for example, anything 2x plus 5, f of x can have any value. So in that case, the differentiation is going to be e to the power of f of x as it is times the differentiation of the power then. Okay. So if I ask you to differentiate e to the power of 5x, what are you going to get? Using the rule, you're going to say that the differentiation of e to the power of 5x is e to the power of 5x times the differentiation of the power, and the differentiation of the power is 5. That is the differentiation. Now let's look at e to the power of x square minus 3x key differentiation. Differentiation of this is going to be this term itself times the differentiation of the power, which is
2x.
2x minus 3. Okay, then for simplification, you can multiply e with x square minus 3x minus 3 e to the power of x square minus 3x if required. So the bottom line is that if we have e raised to the power of ax plus b, the differentiation is going to be e to the power of ax plus b times the differentiation of the power a. This is the general rule that you should remember. Now you tell me, how would you differentiate part C?
Would it be minus 3x square e to the power minus 3x?
But you are forgetting here one thing, that these are two functions that are being multiplied together.
Oh,
So we are going to introduce the product rule. So differentiation of this is going to be obtained using product rule. If this is u and this is v, then uv prime plus vu prime will give you. So what is going to be the differentiation of e to the power of minus 3x? E to the power of negative 3x times negative 3. plus v, that is e to the power of negative 3x, u prime is going to be
2x.
2x. Now you can simplify this minus 3x square e to the power of negative 3x plus 2x e to the power of negative 3x. If I take e to the power of negative 3x common out, I'm going to get minus 3x square plus 2x. Okay, you all can try this part D now. Okay, it's a fraction, so you know what to do. I'm going to take the exam break here. All right, is it done now?
Yeah, sir.
So what is everyone getting?
Is it e to the power 2x into 2x minus 1 upon x squared?
Yes, that's correct.
Yes.
Okay. A curve has an equation y equals to bracket e to the power of 2x plus e to the power of 3x to the power of 5. Find the value of dy by dx when x is 0. Would you agree that these two can't be added up, or you cannot write e to the power of 5x? Is this very clear? You can't add these two, right?
Yeah.
Yes.
Okay. You need to find the value of dy by dx when x is 0. So this is, the whole thing is to the power of 5. So first of all, you're going to simplify the power, like we are going to bring the power down, reduce the power by 1 times the differentiation of these two terms here. So differentiation of e to the power of 2x is e to the power of 2x times 2 plus, don't forget the brackets, e to the power of 3x differentiation is going to be e to the power of 3x times 3. We want to find the value of dy by dx when x is 0. So directly without simplifying, just plug in x is 0. So if you plug in x as 0, e to the power of 0 plus e to the power of 0 to the power of 4 times 2 e to the power of 0 plus 3 e to the power of 0. E to the power of 0 is 1. So that's going to give you 2 to the power of 4. 2 plus 3 is going to be 5. 25. If you multiply all this out, what do you get? 2 to the power of 4 times 5 times 5. 400. Okay.
Yes.
Okay.
Yes, sir.
Now we are going to see differentiation of logs, and the log that we are going to differentiate is the ln form, that is to the base of e. So here, in the following question, you might be asked, required to apply the properties of the logs as well. Okay, so the differentiation of ln x, this is the rule that we are going to remember and apply. Differentiation of ln x, this is the only log we are going to differentiate. So ln is to the base e. So differentiation of ln x is going to be equal to 1 upon x. 1 upon whatever is over here, ln bracket, whatever is inside bracket, you're going to write that in the denominator, 1 upon that denominator. That is the differentiation, that is the simplified differentiation. So as a general rule, I can say that if I have the equation as y equals to ln f of x, where f of x denotes any function, so the differentiation is going to be 1 upon f of x multiplied by the differentiation of f of x. For example, differentiation of ln 2x plus 3 is going to be 1 upon ln ln of 2x plus 3 था, right? So 1 upon 2x plus 3 multiply by the differentiation of 2x plus 3 is going to be 2. So the outcome comes out to be 2 upon 2x plus 3. If you want, you can note this down. Note the two rules down in this example. Kashish, Renu, Vina, any questions still here?
Sir, can you explain it again?
Sure. Where do you want me to explain again? Like from where?
Sir, from the next second step, like you're done.
Okay, if whenever we have a ln of a function, so the example that I gave you was if you have an equation y equals to ln 2x plus 3, to find the derivative of this function, just remember the rule. The rule to differentiate log form, ln form was the derivative of ln form, ln of f of x is going to be 1 upon f of x times the differentiation of f of x. So in this question, 1 upon 2x plus 3 times the differentiation of 2x plus 3, that is 2. Differentiation of 2x plus 3 is 2. So the outcome is going to be 2 upon 2x plus 3. अब ठीक है?
जी सर समझ आ गया. Thank you.
So as a general rule, you can also say that if you have ln, let me write this again. So you can say that if you have an equation in a log form, y equals to ln ax plus b, then dy by dx is going to be 1 upon ax plus b times a. So a upon ax plus b is going to be the simplification. Okay, let's do these examples. How am I supposed to differentiate ln 8x? Apply the rule.
1 upon 8x
1 upon 8x times
into
the differentiation of 8x, that is 8. So 1 upon x is the final answer. Ln 5x minus 7. So if I want to find the derivative of this, that's going to be 1 upon
5x minus 7
5x minus
into
7
5.
into 5. So 5 over 5x minus 7. Ln 2x square plus 5.
1 upon 2x squared plus 5 into
Time
4x.
into 4x. Yes. Okay, try this one now.
So will it be 1 upon 2 root x and then root x minus 10?
Okay, let's solve this. So I can write this statement as ln x minus 10 to the power of half. Differentiation of this is going to be 1 upon. Acha, so what I can do is, if you remember the property of the log, would you agree that this power can come as a product over here? Can I say that?
Yes.
So 1 upon 2 ln x minus 10. Now, if you are asked to differentiate this expression, Since 1 upon 2 is a constant term, it can be pulled outside the derivative sign. So 1 upon 2 derivative of ln x minus 10. Now, ln x minus 10 is nothing but 1 upon x minus 10 times 1. So the
So,
answer is going to be 1 upon 2 times x minus 10,
So you didn't take differentiation of the bracket.
which is 1. X minus
Um,
10 की differentiation is 1. Do you all need time to note this down, or you're done till here?
so I'm done.
mhm.
Okay. Now you may try this. You are asked to differentiate with respect to x. Keep this thing in mind that these are the two terms being multiplied and these are the two terms being divided. So do not forget application of product rule and quotient rule. Simplify करके आंसर बता दें.
And tally.
So I'll have to solve this. U prime is going to be 30x to the power of 5. V prime is going to be 1 over 2x times 2, that is 1 upon x. Derivative is going to be in the form of uv prime, uv prime plus v u prime. So from the first term, it's going to be 5x to the power of 5, then 30x to the power of 5 ln 2x. Now, if you want, you can take 5x to the power of 5 common, 1 plus 6 ln 2x. Okay, that's it. For the second, u is ln x, v is 3x, u prime is going to be 1 upon x, v prime is going to be 3. Derivative is going to be in the form of vu prime minus uv prime over v square. If I solve the numerator, I'm going to get 1 minus ln x, and the denominator is going to have 9x squared. You can simplify this, 3 and 9. 1 minus ln x over 3x squared. That's it. Okay? Is it fine till here, everyone?
Yeah, sure.
Do you
Yes,
need
sir.
time? Do you need time to copy this down, or should I change the slide?
You can change the slide.
Okay. Try this one out. All right. Now, for this question, this curve has an equation of log to the base 2 of 5x minus 2. The first part says show that y is equal to 1 upon ln 2 times ln 5x minus 2. Now, this is the question in which the equation of the curve is not in the ln form. It is to some other base. Okay, and we want to simplify the equation, or we want to write the equation in form of ln. So obviously ln is to the base e, and this was log to the base 2. In the question, the equation of the curve was in the log to the base 2, and in the answer they want you to introduce ln to the base e. So you can clearly see that there is a change of base. And so if you remember one of another property of the logs, that was change of base law. Change of base law says that if I have log a of b and I want to express this in some other log, let's say log to the base c. So I'm going to write log to the base c of this value b divided by log to the base c of this value a. That is how you apply the change of base. So you can see that the base has been changed from a to c now. So if I want to change the base from 2 to ln e, what I'm going to do is for log to the base 2 of 5x minus 2, I'm going to change this to ln, and I want it to be in the form of ln, and I know that ln is always to the base e. So ln of this value 5x minus 2 divided by ln of base 2, sorry, ln to the base e of 2. So if ln2 is just a constant value, so I can write 1 upon ln2 bracket ln of 5x minus 2. That is shown. This was asked to show. Is the first part clear?
Yes, sir.
Now please do the second part. So for the second part now, you need to differentiate the curve. So differentiation of 1 over ln2 times ln 5x minus 2 is going to be, see, 1 over ln2 is just the constant value. Differentiation of ln 5x minus 2 is going to be 1 upon 5x minus 2 times 5. So the overall answer is going to be 5 ln 2 times 1 upon 5x minus 2. You need to find the derivative at x equals to 2. That is going to come out as 5 times 2 is 10, 10 minus 2 is 8. So 5 over 8 ln 2. Make sense?
Yes, sir.
Yes, sir.
Okay. Now you have been given an equation of a curve that is to the log to the base of 4, and I want you to differentiate this curve. So you must understand that the only differentiation of a logarithm that you have done is ln. Okay, so you're going to apply the change of base rule and convert this log to the base 4 of 5x minus 1 into ln form. So if I apply log change of base rule, what can I write in terms of ln?
ln 5x minus 1 over ln 4.
Great, ln 5x minus 1 over ln 4. Now I haven't differentiated up till now. It's better to write like this, 1 upon ln 4 times ln of 5x minus 1, so that you have an idea that 1 over ln 4 is just a constant value. We don't need to, like, this value does not need to take part in the differentiation. So derivative is going to be 1 over ln 4 as it is times, so the differentiation of ln 5x minus 1 is just going to be 1 upon 5x minus 1 times 5. This gives you 5 upon ln 4 times 5x minus 1. All right.
Yes.
Okay. Now, this was the question at hand, and you were asked to differentiate, find dy by dx. Now, this e is raised to the power of y, and that is equal to 5x cubed minus 2x. So, to differentiate this, in order to differentiate this, Okay, you will have to make y the subject first. And to make y the subject, you are going to convert this exponential equation into the logarithmic equation. And that can only be done if you introduce ln on both sides. Okay, this is going from a exponential form to the log form. So if you introduce ln on both sides, y is being the power, y being the power can be written as a product, which is going to give you y ln e equals to ln times 5x cubed minus 2x. Is everyone agreeing with the first step that I've done?
Sir,
Yes.
can you explain again?
Sure. So the question was e to the power of y equals to 5x cubed minus 2x. And I want to differentiate this. I would like to make y the subject first, and that is only possible when I'm going to convert this exponential equation into the log equation, logarithmic equation. And how did I know that I don't have to take lg and instead I have to take ln? Because there is an equation in terms of e. So it's always, whenever you have an exponential equation in terms of e, it's always better that you take the log form as ln. So you take ln on both sides, you apply ln on both sides. Y being the power can be written as a product with ln e. So you are going to get y ln e is equal to ln 5x cubed minus 2x.
Sir,
What? Yes.
why do we need to make y the subject?
Otherwise, how would you find dy by dx?
Okay.
Okay. Now, what is ln e? What is this value equal to?
1.
1. Does everyone know why ln e is 1? Ln is always to the base e. That's understood. That's why we don't write it. And ln e of e is 1. That is because if you want this answer, then what you are going to do is you're going to convert from this log form to the exponential form. E raised to the power of x is equal to e raised to the power of 1, and that is only possible when x is going to come out as 1. That's why ln e is 1. Okay, so ln e is 1. So this gives you your equation y equals to ln 5x cubed minus 2x. Now you can differentiate this happily. Dy by dx is going to be
1 on 5x cubed minus 2x into
times
15x minus 2.
into
15x squared.
15x minus 2. Great. So that's our final answer, 15x minus 2 over 5x cubed minus 2x.
Sir, won't it be 15x squared minus 2?
Hmm? What? 15x squares. 15x squared. Right. Yeah. Done. Let me know if you have any questions still here.
No, sir, it's clear.
No, sir.